In the previous video we spoke about some of the features you might find in the zone of accumulation and the zone of flow. In this video we're just going to get a wee bit more detail about how these features are actually formed. So the one in front of you just now is a formation of a quarry. Now below it is a basic description of how a quarry is formed. You can see snow collects in a hollow. This would be a good time to talk about how the snow gets there. You can add in a bit about the avalanche. It then eventually turns to ice. This is where you can talk about neve, and what helps form the ice is the lapse rate. Alright, and at the bottom is a brief description. It's a rounded hollow with a steep head or back wall, and you can describe it as looks like a bit of an armchair. Yep, this is a really good diagram. It shows us that quarries also lead to other features, and you can see in the diagram we've got sharp ridges around the sides and the back of the quarry, which is our steep sides and back wall. This diagram is fantastic. Yep, this might be an idea to pause the video here and draw this diagram with the annotations. This is going to pick you up a lot of marks. Alright, so draw the diagram. You've got the different steps underneath it. If you can form this into a paragraph with the diagram, we're going to be picking up a lot of marks here. Don't need this diagram, it's a wee bit simpler, it's a bit of a cross section. I prefer the other diagram as it's a lot more detailed. What we have here is a great example of a quarry here. If you can look at the map, we can see round this area here is our contour line pattern. So the contours are very close together to indicate it's steep at the sides. You've got the steep back wall, and then you've got steep sides there. So when looking for a map and a contour pattern, I'm going to come into that in more detail further on in the video, but this is a really good example. Again, this photo shows a sort of quarry with a tarn. It's the same one, we're just looking at it from a different angle. So this area here is where the meltwater might form, and again you've got the steep sides and the back. And so a wee explanation of how that tarn or lock gets there that we've seen just previously. Now this is really good as it talks about rotation. It's got the processes involved. If you can compile this into a paragraph, again we're looking at a fantastic answer for the formation of a quarry. Moving on from the formation of a quarry, we're going to look at the formation of an arête. Now an arête forms, or can form, when two quarries form side by side, but the description of it is it's a very narrow, sharp, knife-edged ridge which forms the side walls of quarries. Now you can see in the pictures here how sort of sharp and thin it is. It can be fairly dangerous to be walking on. Again, you've got quite a detailed diagram here of a pyramidal peak. Now a pyramidal peak is a further feature that we look at during glaciation, and it forms when there is 3 or more quarries back to back. You've got your arêtes in between each quarry, and then when they meet they form this pyramidal peak. And you can see at the top here you've got your arête here, your arête here, and when they meet they form this pyramidal peak. Now the one on the left, you can see there's an arête there, and just in the background there's an arête which would then form another pyramidal peak. This is a perfect example of a pyramidal peak. You've got your arête there, and you've got one on the back side, and this is the Matterhorn, and it's a very distinct and famous feature. Just a small task for you to consolidate your learning, so it might be a good idea to pause the video here. Now areas of glaciation are sometimes turned into national park because the scenery is so breathtaking that large amounts of tourists want to visit these areas to take pictures and experience the scenery firsthand. Now what we can see here is Cumbria in the Lake District is a national park. It's one that we kind of focus on, as well as the cairngorms throughout this unit. Now the map here shows us various different features, and what we're going to do is we're going to go into this a wee bit more detail further on in the video. So again we've got a picture of a tarn. We can see the steep sides. We've got the quarry lock there in the middle. I'm just going to zoom in on that map. Yep, so we can see the very steep sides and the contour lines expressing that again at either side and at the back of it. And just under this arrow we're going to have strident edge, and you can see swirl edge. These are arêtes, yep. What we have here is the example and model answer when asked about the formation of a arête. You can see we've got quite a detailed diagram here. We've got two examples that you can add in to your answer. We've got dorsal and afterthought in the cairngorms. This might be a good idea to have a read through this, pause the video and see where you can maybe pick out key things that you would like to add or need to add when you're writing your answer. Again, if we zoom in on this bit of map here, we can see strident edge there, yep, is a really good example of the contour pattern of an arête. Swirl edge here also has it, so you've got very steep sides. Yep, sometimes you'll get the image for cliffs there, and that will show you on a map that there is an arête there. This is a really good part of the video as it marks where you find scree slopes. So scree, you've got these black lines and dots here to indicate the individual sort of rocks. You've got quarries in green. You can see this horseshoe pattern. A good tip is sometimes if you put your thumb over it, it follows the shape of your thumb. We've got a tarn, and with a tarn we know, or a quarry lock is, we've got a quarry, and in yellow we've got the arêtes, so you can notice, yep, the distinct contour patterns of the arête. And this might be something that you need to work on if you've never studied geography before, but can be done fairly easily. We are now going to move on to the zone of flow and some of the features and processes involved in this area. And one of the main ones is the formation of a U-shaped valley, which is sometimes called a glacial trough. Alright? Again, you've got a description with quite a detailed diagram. It might be an idea to get a copy of this in your notes. So a U-shaped valley looks exactly like a U if you cut it into cross section. So you've got steep sides, you've got a flat floor, yep, so steep sides, flat floor, and then if we look at on a map, what we've got is we've got the contour lines showing us the very steep sides, yep, and we've got this area here of white which indicates it's flat, yep, so steep sides and a flat valley floor indicate a model U-shaped valley on a map. So again, you can see this is a perfect example. You've got steep sides, you've got the flat floor, and you've got steep sides at the other end. Yep. Now, this valley used to be occupied by a river, and it had sort of interlocking spurs, but we'll go into that in a wee bit detail further on in the video. Again, U-shaped valleys can be massive, so in Switzerland here, they actually have a settlement on the floor of the U-shaped valley, which just gives you an example of the size of these valleys. So, like mentioned, we've got the contour lines here, yep, which can show us interlocking spurs. If you imagine that, take both hands and your fingers interlock, what's happened then is the glacier, because of its sheer power, is bulldozed through these interlocking spurs, and we've called them truncated spurs. They've been cut off. Yep. So we've got the U-shaped valley when the glacier retreats, and you've got the truncated spurs at the side of the U-shaped valley. Now, fjords, there's plenty in Scotland, are formed when a glacial valley, so a U-shaped valley or a glacial trough, actually gets drowned by the rise in sea levels, so the whole valley, you can see, is covered in water. Hanging valleys are smaller valleys, and you can see in the pictures here, that hang above a much bigger U-shaped valley, and these are sometimes adding water, and they can be very easily identified by waterfalls on maps. So again, if we just zoom in to the map here, we can see here we have a waterfall, and as the contour lines run almost at a right angle to this river here, we notice a waterfall, and we can identify that as a hanging valley, and it will feed into a much larger valley. Yeah. So here is a simple diagram which shows you different contour patterns. So a V-shaped valley has the contour patterns in a V. Now after glaciation, the U-shaped valley, like we've seen on the OS map, has steep sides of contour lines, and in this area would be white, which would indicate a flat floor. Here we have the hanging valley. Yep, you see the right angles to the river there, and eventually that feeds into this bit area here, which would be the bigger U-shaped valley. Now, sometimes when a glacier melts in a U-shaped valley, it leaves behind a ribbon lake. Now, this is a perfect example of a ribbon lake, called so because it is very long and very thin, and it follows the shape of the valley. So a ribbon lake can be formed when either an area of softer rock is eroded away quicker and deeper and leaves that hole to be filled with water, or when there is a natural dam formed through moraine, and we'll look at moraine further on in the unit. This is the perfect model answer for a ribbon lake. Again, this diagram is particularly good. It might be an idea to pause the video here, and then from there you can take a note of the model answer and the diagram so you have a copy of it in your notes.